Hey guys, it's Chris at Highline Guitars. You're watching another one of my YouTube guitar building videos. If you're new to my channel, welcome. I hope that by the end of this video, I'll have earned your subscription. And of course, to everybody who's watching, if you enjoy this video, please give it a thumbs up. What I'm going to be talking about in today's video is I'm going to be continuing with my explanation of how I build a 3D model of a guitar neck for CNC purposes. Now, in the last video, I laid out a full-size, full-scale drawing of the guitar neck in Adobe Illustrator. And now I'm going to use those elements to build the 3D model in Rhinoceros 3D. And this is all part of my video series where I am going to be building a 6-string multi-scale guitar. So let's jump on the computer and get started. All right, so I've launched Rhino 7 and I've created a new document. The first thing I've got to do is import the Illustrator file that I created in the last episode. So I'll navigate out to that and I'll just do a basic import. I don't change any of the settings that come up. I just leave them as is and I'll drop it right into Rhinoceros. And this is how it looks. It's a 2D drawing just like it was in Illustrator, but now it's lying flat in a 3D space. Now, the first thing I'm going to do is I'm going to work on the headstock. So I'm going to select the back of the headstock, the part that has the volute, and I'm going to raise that up 0.5625 inches. So that's how thick I like to make the headstock. Then what I'll do is I'll select the holes or the circles that will become the holes for the tuners. And then I'll select both the top and the back part of the headstock, and I want to rotate it 10 degrees, which is the angle that I like to do my headstocks, but it rotates it around the center of the gimbal. So it drops the neck where the headstock meets the neck. It drops that down below the lines that were drawn for the neck. So I've got to bring that back up and lock it to that position. Next thing I'm going to do is, as you can see, because of this angle, where the nut will be placed at an angle, it's no longer matched up with that side. And it's just because of how it rotates. So I'm just going to click that and drag it up, snap it right to that edge. So now I've got everything into position and at the right angle. But as you can see, the volute needs to be worked on because it's still just flat. And well, I should say it's at an angle, but it's flat. It doesn't curve the way a volute normally curves. So I'll go into the right view and I will drag up those endpoints to create sort of the shape that I want for the volute. And right now what I'm doing is I'm building the framework for the headstock. And this framework is going to support the surface that's going to be applied. So I have to build the framework first. And what I'll do now is I'll use the polyline tool to connect points between the back and the top of the headstock shape. And what that is doing is it's creating a framework sort of like what you would see as a framework for a house. They build out the framework and then they cover it with the outer material as well as the interior drywall material. So in this case, we're just going to be covering it with a surface, but I have to have a structure for that surface to adhere to. Now, the way I do a surface is I use the surface from network of curves. So I need a network of curves. I can't just select one whole surface or shape and then surface it. It has to be a network. So they have to be separate. So what I'll do is I'll select and then explode that shape, which breaks it into separate individual line segments. And then what I can do is I can start to build a network from those. And I'll do the same thing with the top that I did to the back. I'll explode it. But what I need to do is to surface it, I need to have at least 3 curves selected. And those curves have to be enclosed. It has to be 3 or 4 curves. It can't be more than 4 and it can't be less than 3. So here I've got multiple segments and I want to join those together to create one line segment. So I'll shift select each one of those lines and then I'll press J on the keyboard and then return, and that connects them all together. So now I can select these three, but I can't select the volute to close it because it's too many lines and that shape is too extreme to get a good surface. So what I'll do instead is I'll grab my poly tool and I'm just going to click in this corner and drag a line down and click in the other corner. And that forms a line which closes that part of the headstock, the front part of it. And then I'll do the same thing with the other side. This will just make it easier and more efficient to select those elements, as you see me doing here. And then I can fill it with a surface. So I'll go up to the surface from network of curves, and that's what you get. And I leave the defaults as they are. I don't really, there's no reason to change them. Sometimes it's necessary if there's a problem with the shape, but typically if there's a problem and you can't get that surface to work right, you've got to just redo your shapes until it will work right. So I just leave those default. So now I've got both sides surfaced. Now I can start to surface around the perimeter, and it's just a matter of selecting the 4 lines that form each shape along the perimeter, and then I repeat that surface from network curves. So now I'll do this last portion here. And you can start to see how the headstock is taking shape. Now what I need to do is the tuner holes. So I'll select each one of these circles that represent the tuner hole. And once I have those selected, I can then extrude them. And the best way to do that is to go into my right view. And you can see where they're selected. And then I'll go up to Surface, Extrude Curve Straight. And I can drag that up as far as I want to, but if I get really close to the headstock, it'll snap to the back. So then I'll hit Return. And now I have my extrusions for the tuner holes. So I'll select each one of those. It can be kind of tricky selecting them. You have to move the cursor right over it. Then I'll use the trim tool and I'll click right in the center of each one of those extrusions. And that deletes the surface right over where that tuner hole is going to be. So I'll do the same thing on the back side. And it's basically I'm drilling out the tuner holes here. So once it's done, I'll click done, and then you can see how we now have the basics of the headstock shape complete with the tuner holes. So now what I'm going to do is I'm going to select these curves here that form the shape where the headstock blends into the rest of the neck. And I will surface that as well. So you can see, and this is the thing about multi-scale guitars with an angled headstock. Because of the angle of the nut shelf, you have this kind of twisting transition between the neck and the headstock itself. And then on the backside, I can select and surface the area that's going to be the volute. Once I have this done, to continue working, it's sometimes a good idea to select those surfaces and then I'll hide them so I can see my work area a little more clearly. I'll even go as far as to hide the truss rod slot elements because I don't need those yet. I won't need those until much later on. So what I'm going to do now is start building the structure for the back contour of the neck. And to do that, I'm going to select that contour template shape. It's a cross section. And then I'm going to use the rotate 2D tool to rotate it up 90 degrees so that you can see that's how it looks once it's been rotated. And I'll do the same thing at the heel end of the neck, because remember, this shape, the contour shape of the neck, it has a start up towards the headstock and then a finish back towards the heel. So I'll rotate this one up 90 degrees as well. And so now I have those shapes oriented correctly. And then what I have to do, this is where things get a little bit complicated. But in order for a contour to work its best, or as most efficiently as possible, and to look correct, you need to build out the structure. So the more structure you have for the surface to adhere to, the better. So what I have to do is break apart these lines and then split them into segments. And I'm going to split each of these curves into a total of 8 segments. So I'm going to use the split tool with the point feature, and I'll hover over the line until I see the word midpoint, and then I will click to trim it right there at the middle spot of that line. And I'll do this on each side of the curve. And I'm going to do this to both the front contour curve as well as the back contour curve. Now, one of the issues that I've noticed sometimes with curves in Rhino is that the start part of the curve sometimes has 2 curve points when it only really needs 1. See, if I select the other end, it's just 1 point that you can select. But when I try to select the point at the other end, I have 2 curves to choose from. And I don't want 2 curves. That will cause problems when I try to surface it. So I'll select one of those curve points. It doesn't really matter which one, and I'll delete it. Then I'll go over to the other side, and I'll do the same thing. I'll select one of those curve points and then delete it. And if you create a surface and notice that you've got some strange wrinkling at some point, it's often because there are 2 points where you only need to have 1. So that's just something to be aware of. But here I'm at the heel end of the neck, and I'm splitting that contour into a total, it'll be a total of 8 segments here. And then, like I did before, I need to delete that extra point down at the end. And I'll do that on both sides. All right, so now to build the framework for applying the surface to, I need to connect these segments together, the segments at the headstock as well as the segment at the heel. So to do that, I'll select the 2 segments that I want to connect, and then I'm going to use a polyline, and I will connect the end, as you see me doing here, from one segment to the other. So I'm basically creating, it's almost like a skeletal shape. And these lines, think of them as being, like floor joists or rafters, or another way to think of it is if you were to take the skin off the Hindenburg, you would see it's not a balloon that's filled with air. It's a huge, massive aluminum structure of girders and beams, and that's used to support the outer skin. And then inside of that structure are bags filled with hydrogen. So this is the same kind of an idea. Is I'm creating this framework structure that will support the surface, which can also be thought of as a skin. And once I have that done, you can see I've got this shape now, this structure, which I have created. Now, in order to build the structure where the volute transitions into the contour shape, I had to create the structure for the contour shape, because what I'm going to do now, and again, this is going to seem confusing, but it will make sense as I go along. I need to extend those lines that I just created. So I'm going to extend them about 3 inches, and I'm using the extend by arc command, and I will click at the end of those lines, hit return, and it will automatically extend the line to a length that I have designated, which is 3 inches. And then I'm going to select the perimeter shape of the neck, and I'm going to break it apart into separate segments by using the explode tool. Then I'm going to go back to extend curve by arc and extend those 3 inches on each side. And the reason I'm doing this is because I'm going to use those line extensions as a guide for building the structure for the transition from the volute into the back of the neck. So now I've got one of those volute lines selected, and I'm in top view, and you can see where those straight extended lines intersect. And what I want to do is I want to use my split tool with the point option, and I want to split that line right where it intersects with the curved volute line. And they're not actually physically intersecting one another. The straight lines are actually running underneath it. But when you look at it from the top view, it appears as though they are intersecting. And when you use the split tool with the point option, the cursor will snap right to that spot. And then I can left click and then right click, and that splits that line right where those two lines intersect. And this is so that I can build out the rest of the structure. And so once I've done one side, I need to do the exact same thing on the other side. Now, once I have the volute curve split, I can start building out the structure of the contour as it transitions from the volute into the back contour of the headstock. And I'm going to use my curve tool, and I'm simply going to be drawing curved lines which link the volute curve to the contour curve at the start of the contour. And to do this, I'll select one of the volute segments, and then I'll use my control curve tool, and I will click on the end of that volute curve, and then I will drag it down to that line. And when it says perpendicular, I will click once, and then I will drag the line over to that the start of that neck contour shape. And I know this probably looks confusing, but this is how I get a precise shape that I know I'm going to be able to apply a surface to that isn't going to have any issues. Now you'll notice as I'm drawing lines, a very small gray box appears next to my cursor. And what that is, it's a dialog box, and it may be really hard to read what's in that dialog box, but it's going to be one of the words that you see on the lower left of the screen where the check marks are, end, near point, midpoint, center, intersection, perpendicular. That's what is appearing. And it's based on where the cursor is over the structure. So you have to be aware of what it's saying. And if you don't connect to the right spots on your structure, the surface isn't going to build correctly. And it takes a little bit of practice and trial and error to understand how that works. But once you figure that out, it's much easier to build out the structure. So I've got the curves that form the transformation from the volute into the back contour. So I have to build out the rest of the shape around the sides in order to get a quality structure here. And this can be difficult to do. It takes a lot of trial and error and experimentation to do this. And the reason I'm not going into a lot of detail here is because every neck you do is going to be a little bit different. But as you do these, build these necks, it becomes apparent and obvious as to what you need to do in order to build a structure that's going to form properly. But because I'm using the surface for a network of curves, I have to remember that I need to have at least 3 lines that are enclosed to form a structure that can be covered with a surface. You can't have 5, you can't have 2. It's got to be either 3 or 4. So it takes a lot of kind of planning and strategy to figure out exactly how you're going to do this on some of these complex shapes. And that's what I'm doing here to get the side of the neck where the volute is. I've got to figure out the best strategy for building those shapes. But then once I have that done, I can select the perimeter shape of that volute and join it all together by hitting J return on the keyboard. And then I'll do the same thing with the start of the neck contour. I'll select all the segments, press J and hit return. And that makes it one line. Then I can select those two. Then I can select all those curves that I have just drawn. So I'm essentially selecting all of the structure components for this portion of the neck. And then I will surface that with a network of curves, and you can see how it now forms this nice transition from the volute at the back of the headstock down to the start of the contour for the back of the neck. Then I have to finish building out the sides the same basic way. And I can then select and join these lines here. And then I will select all 4 of the lines that form this area, and I will do a surface from the network of curves. And as you can see, it's starting to take shape the way I want it to. And then once I have all those shapes surfaced, I can unhide the surfaces that I created earlier. And we can now see how this is all starting to come together very nicely. Now, as part of the process of building that volute transition, I deleted the lines that form the perimeter shape of the neck. So I need to bring those back in. So I'll just simply use my polyline tool to redraw those lines. And of course, when I brought back the surface for the headstock, it also brought back the lines for the truss rod slot. And I still don't need those yet, so I'm going to reselect them and hide them again just to try to unclutter the area that I'm going to be working in. And then the next thing I'm going to do is I'm going to build out the heel and the transition from the heel into that back contour. So I'm going to raise the heel shape up about an inch. And that means the heel will be an inch thick. So what I have to do is, once again, I have to extend the curve by arc and then extend these lines 3 inches so that I can use them as a guide for building the contour or curved structure shape for that transition from the heel into the back contour of the neck. So then I'll select that heel and I'll explode it so that it's in segments. But then, like I did with the volute, I need to break those up where they intersect or cross over the lines that I extended. So I'll use my split tool with the point option and hover right over that intersection and left click, and that splits it. And I'll just continue around the length of this curved shape. And then once I have those curves split, I can start drawing the structure, the structure lines for that transition. And I'll use my curve tool, drag it straight down to the line forming the perimeter shape. And then I'll select that segment and then click straight down to where it says perpendicular on the next line, drag it over to the neck contour shape and complete that line. And I'll just do this all the way around until I have created the skeletal structure for that transition. And with that structure finished, I can then select those segments that form the heel, the front leading edge of that heel. And I'm going to join them together by pressing J and return on the keyboard. Then I'll do the same thing with the contour, the neck contour at the heel. Select all those elements, press J, hit return. Now they're all one line. So then I can select all these lines that I have created. And then I will use my surface tool and surface that network. And as you can see here, we have a nice surface. But if you look closely, you'll see that there's a funky little curl going on. That's what happens when there are 2 points, or if a point isn't lined up correctly with the segment. So what I have to do is I'm going to select one of those extra curves that I don't need, and I'm going to delete it. Then I'll redraw. I'll go to the other side first, and I'll see if it's the same issue there, which it is. And I'll delete the extra curve point. And then I will redraw that curve that transitions from the heel to that neck contour curve. So now I can select all these elements once again, and I'll create a new surface, which should hopefully not have that peculiar looking curl on the end of it. I'm not sure why Rhino does this, but it does. And as you can see, it's now a perfectly formed surface shape. So now what I'm going to do is finish building out the heel, and I need to connect the corners with a polyline. So I'll draw those in. And then what I can do is select those shapes. Now first I'll do the bottom of the neck heel, and I'll surface that. Now, before I do the sides of the heel, I'm going to select this contour curve, and then I'm going to use my trim tool, and I'm just going to click on those line extensions because I don't need those anymore. So when I click on it, they are cut back to that contour curve, because the contour curve acts like a it's sort of the it tells the tool where to cut the line. So here I'm going to select the contour curves as well as the lines forming the structure, and then I will surface that. And this is where you'll really begin to see the neck taking shape. So once those are all selected, I will go up to surface from network curves, and there we have the back contour. And I just have to finish surfacing those elements in the heel, or around the heel. Now when I flip it over, you can see that the top surface where the fretboard is going to be attached is still wide open. I need to surface that as well. And the perimeter is actually made up of a bunch of line segments that I had created earlier as I was building out the surface structures for the rest of the neck. So I have to join those together to form 4 separate curves that are enclosed. So I'll grab each of those segments, and I'll do one long curve on each side, and then one curve at each end. So once I have those all joined together, I can start selecting them. And that forms a 4-sided shape enclosed. And then I can just surface that from a network of curves. And now I have, this is essentially the entire neck with just one other feature that needs to be generated, and that is the truss rod slot. And to make that, I first have to bring it back because I hit it earlier. So I'll go to Edit, Visibility, and Show, and that brings back those elements for the truss rod slot. And I'm going to use a surface extrude, which will extrude the rectangle as an open-ended box. And once that's done with that polyline still selected, I'll move that down to the bottom of that box. And you can't see it here because it's covered by all the surfaces. But what I'm essentially creating here is a channel. So once I've created that channel, I can then use the channel itself to delete that portion of the surface that's covering it. Now, as you can see, the front of the truss rod slot extends up above the headstock, where the headstock is curving down towards that the angled portion of the headstock. So what I need to do is I need to use those components to delete the surface area so that I reveal the slot. Then I can select the surfaces around it and then use the trim tool to delete just those sections that are sticking out above the truss rod slot. Then I can select the extrusions that I created earlier and use the trim tool to delete the surface that's covering the slot. So you can now see the slot itself, but it doesn't have a bottom. And that's the reason why I moved the polyline down to the bottom of it. So I can select those polylines and then I'll surface those. So now it has a slot that has a bottom to it. But as you can see at the front, I still have pieces that are blocking the slot. Those are just remnants from the surfaces I created earlier. So I can just explode those elements and select the sides and the bottom of the slot, and I'll use that to trim away those excess pieces. So I'll use the trim tool and I'll just hover over where I want to break that surface open. And then once that's done, I can select the piece and delete it, and you can see I've now trimmed that away. So I'll do the same thing with the front part of the slot. And this is where the adjustment nut for the truss rod would sit. Or this is actually where the tool you use to adjust the truss rod accesses the adjustment nut. So I'll select those components and then I'll use the trim tool and click where I want to trim away that material that it's blocking the slot. And then I can delete that. And there we have it. All right, and at this point, the neck is completely finished. All that's left to do is to save it, give it a name, and then I need to export it. And the way I export it is I use, there's a lot of different options that you can export these files to from Rhino. However, for the CNC process of writing G-code, I use the STL stereolithograph option, and that's how I'll export it. And under STL mesh options, I always type 001 millimeters. That seems to be accurate enough. And I'll click OK. And I like to do binary as opposed to ASCII because binary files are smaller and I can't tell any difference between the binary and ASCII as far as quality is concerned. So once that's done, the neck is finished, and then we can move on to the body. All right, guys, well, that pretty well completes this two-part series, which is part of the overall series where I'm building the 6-string multi-scale fan fret guitar. And as you can see, this guitar neck only took, the modeling process only took about just under 40 minutes to do it. And it would actually go a lot faster if I wasn't trying to video and narrate the video at the same time. So really, once I have the Adobe Illustrator drawing done, the actual modeling process takes me about 30 minutes. Now, it's probably going to take you a little bit longer if you've never used Rhino before, because building 3D models is complicated. In fact, I always laugh when people say that building guitars with CNC technology is cheating because all you have to do is push a button and watch a machine make your guitar. They don't see this side of it. This is where the real skill lies. And if you've ever tried building 3D models, you know how difficult and complicated it can be and how much skill is involved. Really, what you're doing is you're trading hand building skills, you know, the skills of using chisels and planes and spoke shaves and files and that sort of thing, for the skills of using 3D modeling software and tool path selection and G-code files, writing G-code files. So at any rate, I hope you've enjoyed this video and get something out of it. And then future videos, I'm going to be building the model for the body of the guitar. So be sure to check that out as well. But in the meantime, as always, take care, stay safe. Click the subscribe button, click the like button, and I hope to see you in the next episode.